This video is the second one in the series about pfSense and UniFi routers migration. Previously, we started the series with an initial setup video. In this one, let's talk about firewall rules. In fact, the firewall rules itself, it's a big topic already. To avoid a super long video, I'm going to break it down to 3 ones. First one, this video, let's talk about in general what's the methodology and the best practice for different routers. Next one, let's talk about how do we set the rules up in different routers. And in the third one, let's talk about a special case, which is the guest network. On the screen, I have the web UI to the 3 different routers open at the same time. Here in the left side, you see the pfSense firewall rules. Right side, the top part is the USG-Pro, and the bottom part is the UDM-Pro. As you may see, the two UniFi routers, they look almost the same. If you are from the UniFi world, you may immediately get surprised when you see the almost nothing one rule configuration in pfSense. In the one part, you see nothing. You may wonder what it means exactly. Does it mean it doesn't allow anything? Can I even access internet without doing anything extra? But if you are from pfSense world, then you check the UniFi router settings. I bet your first question will be, okay, why it breaks down by one LAN and guest? I even don't have guest configured in the beginning. Why I see guest here, right? And why for one I see 3 different tabs. For LAN I see 3 different tabs. And why UniFi even wants to differentiate in, out, and local, right? That may be your immediate response. And then when you see the default rules, you may ask, why UniFi even have default rules? Why it differentiate established, related, invalid? Those differences are related to the different mindset or different methodology, different approaches taken by pfSense and the UniFi routers when it comes to the firewall design and the firewall rules design. First, let's talk about the concept of stateful firewall. This is the stateful firewall web page on Wikipedia. Even though it's a very short article, you can see some important information. For example, it mentioned that it keeps track of the states of network connections and give them labels like listen established, and once in the table, all related packets are streamlined allowed. The routers we are going to talk about, the pfSense and UniFi routers, they are all stateful firewalls, but the way they support the state is very different. Let's look into that. In pfSense, if you go to diagnostic, then you have a menu item for states. This is where you can find the state table maintained by the stateful firewall. As you can see, you have for which interface, what's the protocol, what's the source and target IP address, and what's the current state. Based on this table, the firewall will know whether a connection is already established, or it will be a new connection, or whether it's a related connection. So all the good information is there. Based on that, the firewall can determine what's the next action in combination with the firewall rules definition. But in UniFi routers, for both USG-Pro or UDM-Pro, they don't expose the state table in the UI. In UniFi routers, for example, this USG-Pro, when you create new rule, see here, you can indicate protocol, right? And then in the advanced section, you have the states setting. So you can choose the rule applied to what states, either new, established, invalid, or related, right? So it seems it simply demonstrates, okay, this is a stateful firewall. It makes sense if you first look at it. But you may wonder why in pfSense, if I go to firewall rules, if I add a new rule, you see no place to define the states. What that means? Okay, pfSense claims to be stateful firewall and even has a state table exposed on the UI. Why I cannot find anywhere to specify the states? In pfSense, when you create a firewall rule, here if you say pass, and here you indicate a interface, what it means exactly. It tells pfSense when a traffic first time it comes to the interface, it enters the interface. pfSense will create an entry in the state table to record this connection. Then the traffic go back. If the traffic is already recorded in the state table, it will be automatically allowed. So here you only say pass for an interface to indicate whether you allow it to enter your interface. When it go back, it's automatically allowed. Another interesting thing, if you check the UniFi firewalls, you can see it has 3 major zones. That's what it's called in UniFi. So you have one zone, LAN zone, and the guest zone. In my understanding, it's something inherited from the edge router world. So in edge router, different interfaces are grouped into different zones just for more user-friendly grouping and managing. UniFi, USG, and UDM inherited that feature. And in pfSense, it simply gives you one tab for each interface. Personally, I like the pfSense way, but it's not big deal. You can use them achieve the same thing. It doesn't matter how the interfaces are organized. If you really like the UniFi way, in fact, in pfSense, you can go to interfaces and you see a interface group. You can flexibly create whatever interface groups you like. You can create something similar to UniFi or totally different. Now let's talk about the rule methodology. In pfSense, we explained how the state table works. All the rules you create in the interface tabs, for example, WAN or LAN you see here, they are called interface tabs. All the rules you create under these tabs, they are always in the inbound direction on that particular interface. So for example, for LAN, traffic initiated from the LAN is filtered using the LAN interface rules. For WAN, the traffic initiated from the internet is filtered using the rules defined in the WAN. So it's very simple, very clean methodology because you have the state table maintained by the system, or the reply traffic is automatically permitted by this state table entry. But there is an exception, which is in the floating rules. If you try to create a floating rule, in the directions you see in and out. If you really want the way in UniFi, you do have the option. But it's not because pfSense think the inbound or outbound direction is necessary for a rule. No, it's to make it more flexible when it works with this interface setting. For floating rule, when you define a rule, it can be applied to multiple interfaces. Sometimes you want to say for the interface combinations, what direction you want to apply. For example, you can create a outbound rule on one interface and it applies to multiple internal interfaces. You can significantly reduce the effort to create multiple rules. According to pfSense, outbound rules are never required because filtering is applied on the inbound direction of every interface. In UniFi, whenever you define a rule, you have to indicate the states, and you need to make sure your rule is defined in the correct direction. In UniFi routers, firewall rules are applied to a direction. There are 3 different directions. In applies to traffic that is entering the interface. Out means traffic exiting the interface. And the local means the router itself. It is the destination. Let's just check the default WAN rules. So let's think about from your local network, from your home. Your local network traffic need to go out of the WAN interface. So let's check the WAN out first. Here, nothing. What that means, we will talk about that later. It has something to do with the default rules. But for now, basically you can think by default all the LAN to WAN traffic is allowed. Let's say you access Google, right? And Google send you back the web page. It will go to the WAN in direction. There are 2 different rules generated by the system already. The first one is allow all the valid sessions, and the second one is the drop the invalid state. The pfSense way is much more clean because by default it only applies to in direction, and when traffic is back, is automatically allowed or disallowed based on the state table. Sometimes it's not very easy to understand what in-out local means in the UniFi router settings. So local is very easy. That means the traffic that is destined for the UniFi router itself. But when it comes to in and out, it's very easy to confuse yourself when it comes to WAN or LAN situation. In means it applies to traffic that is entering the interface, destined for other networks. Out means the traffic is exiting the interface and destined for this particular network. Let's use WAN in and WAN local as example. So WAN in means the traffic is from WAN, which is internet, destined for your LAN. And WAN local, that means it's from internet to your UniFi router. Hope that's easier to understand now. Next topic, let's discuss the default rules. This is a little bit messy because some of the rules are generated, some of them are default, some of them are hidden. For 2 different type of routers, they work differently. So bear with me. Let's start from pfSense. This is an article about PF. In fact, pfSense derives its name from this tool. It's a central piece of software for firewalling. Or you see on the UI, the firewall rules. Internally, it's supported by PF. And internally, whatever you set need to be converted or translated to the rules within PF. Let me SSH into pfSense. Okay, hit 8. Go to shell, then run command pf control ctl, then s8 to display some detailed firewall rule information. Seems it's a little bit too verbose. Let's use sn. Okay, so now you see the concise version of the rule. Even though maybe it's the first time you see them, just by reading them, you may guess where they come from. For example, some of them comes from the default allow any to any rule on one interface. Some of them comes from the Anti-Lockout Rule, which is automatically generated by pfSense. You don't really need to understand this part as long as you know, okay, there's such thing, and what you set on the UI is not really what's internally executed by the system. In pfSense and in UniFi routers, right after you install a fresh new system, you can already notice some automatically generated rules. In fact, behind the screen, the system also has some hidden rules. And then with your future configurations, there may be new generated rules added by the system. A unique thing in pfSense is called Anti-Lockout Rule. So let's go to LAN tab. The very first rule is the Anti-Lockout Rule. See here, for these two rules, you are able to delete, but for this one, no way. Basically, it says from anywhere within LAN, you can access the LAN address, which means the pfSense box itself. You can access these three ports. You cannot drag and drop to move it anywhere. It has to be the very first, the top one. For normal home users, that's very convenient, but if you require a very secure system, it's not a good idea to open up your pfSense box to any machines within your LAN, right? So you may want to change this. And in fact, if you click this setting, it will lead you to the System Advanced Admin Access tab, and you have control to disable the lockout rule. Let me search lockout. Yes, by default it's not checked. If you check this one, it will be removed, right? Then you will risk yourself of being locked out. And there are other ways to secure your pfSense box. For example, to move it to a dedicated management network. No matter whether it's USG or UDM, you have to configure the firewall using UniFi network controller. If you cannot access this UI, that means you cannot access your network controller. Then you have bigger trouble. So that's why I'm not worrying too much about locking yourself out of the UniFi firewall setting. Next, let's talk about anti-spoofing rules. On the screen, you see a RFC 3704. It describes the spoofing behavior and how to prevent it. There may be attempt that a connection comes from a source IP address on an interface where it claims it comes from a network, but the firewall knows it doesn't. Let's go to pfSense. Let me view a temporary file, and the file is in folder TMP, and the file name is rules.debug. This file is pfSense generated and will be used by PF to interpret the rules and generate the final rules. This is not the final rules. It's not your original rule defined in pfSense. It's something in the middle. The reason I want to show you is in this file, you can find the anti-spoofing rules. So let's search for spoofing. Yeah, see here, you can see it's for WAN and for LAN interfaces, it has the anti-spoofing rule defined. Okay, so this is how it works in pfSense, but I cannot find any information about in UniFi whether or how it's implemented. So if you know the answer, please let me know in the comments. In pfSense, it can also automatically generate two types of rules if you wanted to. So let me show you. You go to interfaces, select your interface. In this case, normally you want to do it in one only. So scroll to the end, you see two options: block private networks and block bogon networks. So the first one is easy to understand. If it's not real internet IP address, it's some local network address, you don't want it to appear in your WAN interface. And the bogon networks, similarly, those IP addresses shouldn't exist. So if you receive any traffic from them, there must be something wrong. I don't have them enabled, especially the first private one, because this is my home lab network. This pfSense is within my LAN. Of course, it's one interface will receive the LAN IP address, so I don't want to check this one. I'm not aware of a way to automatically configure these two similar settings in UniFi routers, but you can easily achieve similar effect, especially the first private network one. In UniFi router, you can define groups. Okay, you can add multiple sets of IP addresses, including ranges, to the group. Then when you define your firewall rules, you can use the group instead of fixed IP address. But apparently the way pfSense implemented is more dynamic, more convenient for the users. pfSense and UniFi routers, they behave dramatically different when it comes to default rules. So let's first talk about pfSense. In pfSense, it doesn't matter whether your rule is user-defined or is automatically added by the system. If the traffic doesn't match any of your rules, it will be silently blocked by the default deny rule. So you may ask, what do you mean by deny rule? Because in pfSense, when I just set up the system, I don't see a default deny rule in all the tabs. So what do you mean by that? Let's go to the system to check it in the generated rules. Remember, we mentioned what you see on the UI are not all the rules behind the screen. pfSense does have hidden or default rules. Now I'm in the SSH already. Remember the temporary file we checked previously? It's under tmp and the file name is rules.debug. Search for default. See here, there's a dedicated section. It's called default deny rules. And you can see for IPv4 and IPv6, it denied both the in direction and out direction everywhere. So yes, you don't see them on the UI, but it does exist behind the screen. Don't be confused about the default allow any to any rules in some of the interfaces. For example, under LAN, by default, the system added this very last rule. It's from any to any and it's pass rule. This is not the default rule we just talked about, because this one is just a system automatically added normal pfSense firewall rule. It's not the default rule generated behind the screen. So think about it. Internally, what the rules look like to the system. It has all these rules you see on the screen, and in the end, it has a deny all rule. So this rule you see on the screen, allow any to any, is not the very last rule to the system. We will talk about this automatically added rule in the next section of this video when we talk about the best practice. Okay, now let's move on to UniFi routers to see what the default rules look like over there. In the left, I show you one web page from UniFi. It introduced something about its firewall rules. In the middle of the page, you can find this section. For all the interfaces and the directions, what are the default rule? And as you can see, for one, somewhere it's accept, somewhere it's drop, and for LAN, they are all accept. And for guest, sometimes it's drops, sometimes it's accept. In my opinion, it's a little bit messy. At least I cannot remember for what interface was the default rule. I prefer the pfSense way, which is it universally applied to all the interfaces, all the directions. The default rule is drop rule. Now let's go to the system. This one is USG-Pro. For one in, it's not displayed on the UI. And for one out, you see nothing, right? But here one out is default accept. And for UDM-Pro, it's the same situation. So to make ourselves more comfortable, let's find it out where the default rule exists. Let's first go to the UDM-Pro. I am in the SSH for the UDM-Pro. Let me try to type the CLI command, configure. See, it says not found. Very disappointing, because that's one of the reasons why I still like my old USG-Pro, because even though USG is pretty old and it has outdated hardware, from software perspective, especially from the backend, it's much more better than the newest UDM-Pro. You have to trust whatever UniFi mentioned on the web page about the default rules. Let's try to find it out from the USG-Pro. I'm in the SSH for the USG-Pro. Let me run the same command, configure. Okay, I'm in. Now let me run this command, show firewall. So now you see all the internal settings within the backend, including all the rules, including the default rules. It's a pretty long file, and it has everything you set on the UI. It's LAN section. Okay, we are in the WAN section. See the WAN in. See here, it says default action drop. And if we check the left side for WAN in, yes, default drop, right? Then let's try to get the WAN out section. Default action accept. In the left, WAN out, default accept. We are happy because we confirmed the default rules in the backend. So in the future, okay, forget about this web page. I cannot remember it, but at least I have access to the system. I can check the real setting in backend anytime. Originally, when I planned for this video, I had two major sections. One for the rule methodology, the other one is for best practice. However, after research, I found pfSense already had a very good best practice page for firewall rules, and I don't think I need to repeat everything here. So this section will be very short, and you can read this article by yourself. Just search pfSense firewall rules best practice. You can find this page. It talks about default deny and keep the rules short. You need to review the firewall rules. You need to document it, and you need to carefully set the login settings. They are all very helpful, but let's talk about this default deny best practice. As it mentioned here, there are two philosophies when it comes to access control: default allow and default deny. pfSense strongly recommend the default deny strategy. Your rule set will be minimal. In most environments, you need to follow this strategy. But at the same time, pfSense also realize for some situations, especially for, let's say, small business or home usage, for LAN, many people simply want to allow all traffics within LAN. If you strictly follow the default deny rule, user need to configure many firewall rules within LAN, especially if you have multiple VLANs. So by default, when you just set up this pfSense system, it will generate the default allow rules for LAN, and for WAN, it will still keep the default deny. So this is just a trade-off between the convenience and security. It's not really recommended to keep this way for long term. In fact, in USG-Pro or UDM-Pro, UniFi follows the similar approach, which is basically for WAN, it's deny all, and for LAN, it's allow any to any. But because UniFi has different default rules internally, so it's not strictly deny all philosophy. Sometimes it's hard to enforce deny all. So you have to make sure, if you really want to deny all, in the end of your rules, you need to have a specific rule to deny all. The very last paragraph for this default deny strategy is very interesting. So basically, pfSense says it's wrong if you ask, what should I block? In fact, what you really need to ask is what you should allow. So that's a dramatic change of mindset for most people. If you really want a very secure environment, you should follow the default deny approach. Okay, so this video is already half an hour. It's longer than I expected. Thanks for watching.